Oh, we did. Oh, sorry. Finish. Thank you. I was losing track here. Um, let's do, sorry, 22. And then after 22, we'll go back to 21. So they're telling us this problem is actually referencing mean value theorem. So really, we know we're going to have to go through that process. So they're trying to ask us, what slope can we guarantee at the f prime level? So we know that we can just find the slope between the two endpoints that they provide for us. And then because of the slope of f prime between 2 points is 5/3, we know there must be a place where the slope or the second derivative at 1 is also equal to 5/5. Part B, write Riemann sum. So we find the width component, we find the height component. Uh, for Riemann sums, we've mainly been working with rectangles. We haven't done many examples with trapezoids, but we do. But if it shows up on the quiz tomorrow, want to make sure that we know that area formula. So make sure we memorize trapezoid area, 1/2 width, height 1 plus height 2. I'll try to remember to send out a reminder about that this afternoon. We've been doing mainly rectangles, but trapezoid is also ones that we need to make sure we're familiar with. So our right Riemann sum approximation is 20. And because our graph is strictly increasing, if we're connecting the upper right corner of our rectangles to the graph, all of our rectangles are going to sit above or peaks above the curve, which means we must be dealing with an over approximation. And this is not something that we should memorize. I think this is just, we should be able to just sketch the graph and convince ourselves, okay, the rectangle is above or the rectangle is below. Use substitution for part C. U value is that expression inside the parentheses. We go through U substitution because there is going to be a leftover coefficient that's going to have to stay with our answer. And then once we find our antiderivative, F double prime rises up to F prime. And then bring back our X and then plug in our upper and lower bound and then use our table of values to continue to reduce it down to numeric values. Okay, next part. This is a solving differential equation problem. So I do want to work through this in full with you. Okay, so I'll work alongside you guys. Okay, use substitution on this side. So the left side, we're actually going through a whole use substitution process. On the right side, this is function notation. We can just make that f double prime rise up to f prime without having to go through use substitution there, since there's nothing inside of parentheses except just x. And again, the only reason that we can do use natural log here is because this is a variable raised to the first power, right? If it's any other power, we got to force it up and go through a power rule. Okay, so at this stage, we're done with our calculus. There's two things left to do. We got to solve for C. We got to solve for Y. I'm going to wait to solve for C. I feel like I can clean this up a little bit more here. So I'm going to kind of work towards solving for Y. But a couple things are in the way here. This is -1/2. It's kind of getting, I do want to involve E in natural log to cancel out, but that -1/2 is getting in the way. So I'm going to multiply everything through with -2. To kind of shift that coefficient over to the right side. So now that clears up my left side. I can now involve E in natural log to eventually work towards getting that that Y by itself. No, this is just one giant C. Yeah, I'm going to solve for Y first all the way, and then I can worry about C a little bit later. Multiply everything clear by -1. Get that Y to be positive. That negative times C is just going to still keep it a C there. This is a little messy here. A lot of algebraic steps to get through. Order pair is 0, 1. Yeah, 0, 1. F prime of 0 is -1. That's given in our table. Sorry, this is a little messier than what you'll need to be able to do. So and also just want to kind of point out, sometimes the algebra on the AP exam can be really tedious. Like, oh wow, there's a lot of steps to get to. But the big picture is that the majority of the points for solving differential equations on the AP exam is, can you separate the variables? Can you apply the appropriate integral rule? Can you get to this function level? And from here, the points are going to be less after this because you're just solving for Y, just solving for C. If you're attempting those steps and you realize it's a really long problem on the AP exam, I would not spend a whole lot of time, because if you have this piece, you've earned the majority of the points. you don't want to spend 10 minutes trying to do the algebra, trying to solve for y. There's more points that you should be earning the rest of, the test. So if you get to this stage and you see that this is a problem that is like algebraically it's just not working out, or you're getting lost, skip it, come back to it later. Okay, so that's just a tip for on AP exam. Sometimes the part after the calculus can get a little tedious. So just make a decision in terms of I gotta watch my time. So is it worth it to spend all this time? Maybe I can come back to it later if there's more time. Okay, page 21. Another solving differential equation, but this one is in terms of variables other than x and y. So let's look at page 21. All right, watermelons are beginning to come into season, and warehouses are receiving watermelons over time. There's a strictly increasing and twice differential function W models the total amount of watermelons in the warehouse. dWdt, this is the rate at which watermelons are coming in. It's following this formula 2t times W minus 9, where W is measured in number of watermelons and T is measured in weeks. At T equals 2 weeks, there are 10 watermelons in the warehouse. Write an equation to the line tangent to the graph at T equals 2 weeks. Use your tangent line to approximate the amount of watermelon in the warehouse at 3 weeks. So gather your order pair, gather your slope, point slope form. See if you can do this one. Your order pair is T comma W. Your slope is coming from your dWdt. Normally, your point slope form is in terms of y and x. You can write that first and then adjust to the new adapted tangent line equation that you want to use. Solve for W, and then you can plug the 3 in. Part B, find the second derivative. Remember, this is derivative with respect to time. We want to treat T as our X, and then our W is getting impacted by time. So here's my setup for product rule. 2T is my F, W minus 9 is my G. F prime G plus FG prime. W becomes dw dt because W is getting impacted by time. So, and then the 9 goes away to 0. We want to use the second derivative to determine whether we have an over or underestimation. So we want to be able to plug something in and actually get something in terms of, is this positive or negative? If it's positive, we know it's concave up. If it's negative, we know it's concave down. And we can use that to figure out what's happening with our tangent line, with our linear approximation. So I'm replacing all of my t with 3, all of my w with 14. And then my dw dt is really just this 2tw minus 9. So I'm just taking this, inserting it into that dw dt, and I'm getting a positive number. And really that positive number is enough to tell me concave up. If my graph is concave up, then any linear tangent line is going to sit below the curve. So under approximation, the line is under my curve. Part F, again, we are solving differential equations. So, but again, not in terms of x and y. This is in terms of t and w. So cross multiply, but eventually we want w's on the left and t's on the right. Ends up being u substitution on the left, but it'll end up being u to the first power, so natural log. On the left, power rule on the right. Raise both sides with e as the base. I'm focusing on solving for w first. And then once I get the w, I can plug in my order pair 2, 10 to solve for c. And once I solve for c, I'm putting it back into my w equation. Either of the final forms are fine. I just want to do a quick review of related rates, just in terms of finding derivative. So if you have any empty space, you can probably put it. We're not going to do part G, so you can put this bottom here. Just as a reminder here, if we're finding the derivative, and actually for related rates, every variable is getting touched on by time. So let's say I have v equals pi r cubed. Okay, the derivative would just be v becomes 1 dv dt. Pi r cubed, we know pi is not a variable, it's just r cubed getting impacted. We find the derivative first, so 3 pi r squared, and then we attach what? dr dt, yeah. Okay. Now this can also work for other random equations that you don't recognize, but you just go through power rule, and then you just attach a d over dt for every variable once you apply the derivative. So if I want to find ds dt here, s will become ds dt. Find the derivative for this first, and then attach a d what? dq dt, right? But you do that after you find the derivative. So we just go through power rule, bring down the 1/2, we get 2q to the negative 1/2, and then don't forget dq dt. Try this last one here, see if you can find dn dt. Find the derivative first, and then attach a variable with respect to time for that variable. Okay, so morning help session tomorrow, 7:15. You guys picked up a morning review, so hopefully there's only going to be 2 FRQs tomorrow on the quiz, but I just put an additional one there just for practice. So yeah, study for your quiz. You can additional practice problems are also page 22 through 25 if you want to, or 22 to 26 if you want to get those practice in. But all right, come get your phones.
Just a minor detail, but like here you divided by -1 on both sides. Can I just like subtract 3 and then divide by?
Yeah, that's fine. Yeah.
Here's page 3.
Okay, great. Thank you.
Can I take the first day, so I just have an extra day to make up what I missed yesterday?
Yeah, but Friday, we are starting our review for next Tuesday. So can you make that voice test next Tuesday?
Yes.
Okay.
Well, so can I like, I could be in constant conversation with the afternoon?
Yeah, we do that.